Hello, for today's video lecture, we're going to be talking about finding internal forces via equilibrium analysis. So as a review, internal forces are the forces that exist within a body that must exist to balance out the external forces on that body. So if we have some beam, it's got two supports on either side. I want to know what are the forces kind of internally within the member at cross-section AA. I can imagine taking this apart, looking at the right half, and I could figure out what is the forces and moments that exist within the beam at this cross-section. All right, so how do we find those internal forces? Well, the most straightforward method to finding the internal forces and internal moments at a particular point is to perform an equilibrium analysis of one half of the body, cutting the body in two at the point of interest. So the steps of the process are as follows. Number one, start by finding all the necessary external forces on the original body. Next, you're going to draw a free body diagram of one half of the body, drawing in the unknown normal force and shearing forces and bending moments and torsional moments that are revealed within the body. You're going to write up the equilibrium equations for that one half of the body. And finally, you're going to solve the equilibrium equations for the unknown internal forces and internal moments. All right, let's go into each of these steps in a little more detail. So first of all, finding the external forces. So before we can find the internal forces in a body, you need to know the external forces acting on that body. In a 2D problem, you're going to have two unknown internal forces and an unknown internal moment when you cut the body in two. In a 3D problem, you're going to have three unknown internal forces and three unknown internal moments when you cut the body in two. So these are, in order to prevent all of the motion, you have a fixed connection within the body, so you have all of these forces opposing that motion. All right, so in either case, the number of new unknowns, these new internal forces and moments, will be exactly the number of equilibrium equations you'll have available with equilibrium analysis. So for that reason, we need to have all the external forces solved before we can solve for the internal forces. One shortcut we do have in this is we really only need all the external forces on one half of the body, because if we're only working with the left half of the body, all of the things on the right are simply going to disappear. So we can ignore external forces on one half of the body if we plan to ignore and kind of cut off that side of the body. All right, so finding the external forces is just a traditional statics problem. You can look back to equilibrium analysis of a rigid body for that process. All right, so next step, step two, we need to split the body and draw a free body diagram of one half of the body. So after finding all those external forces, the next step is to imagine cutting the body at the point of interest. So if you know, I want to find the external forces here, imagine making a cross section at that point, and you're going to draw a free body diagram of one half of the body. So either side is going to work. If you cut it in half vertically, you could use left or right. If you cut it in half horizontally, you could use top or bottom. You're going to use whatever is easiest for you. So imagine we've got this, it's kind of like an open chain link here. Imagine I've got two tension forces at the top, a third tension force at the bottom here. I want to know what is the internal moments and forces at cross-section AA. All right, so I could either use the bottom half of this, or I could use the top half. So either one of these two pieces would work. I'd personally go with the bottom half. It's going to make the analysis a little bit simpler. So once we have our kind of half of the body, make sure you only include the external forces on that half. You're going to draw in an unknown normal force, an unknown shear force, and an unknown bending moment at that cross-section. So the standard convention is N for normal force, V for shearing force, and MR for the moment that's going to exist at this cross-section. So I could draw that on the bottom half, or I could draw that on the top half. I don't need to do both of these. I just put this in here for an example. But I do need to do one half of these, this chain link here. All right, so next up, in a 3D system, we will do the same thing, except there's going to be more unknowns. So there's going to be an unknown normal force and two unknown shear forces at the cut, and there's going to be two unknown bending moments and an unknown torsional moment at the cut. So we'd have a normal and two shear, two bending moments, and one torsion, about basically a force and a moment about each of the three component axes through my cross section. All right, next up, step 3 and 4. So if the whole body is in equilibrium, then each section of the body is in equilibrium. So we've got our free body diagram of the one half of the body. And once you do that, simply put together the equilibrium equations, sum of forces in the x, sum of forces in the y, sum of moments, and solve for your unknowns. So you should always have exactly as many equations as you have new unknown internal forces. And then when you solve your equilibrium problems for those unknown internal forces, you should get a value for each of those, again, so long as you've solved for the external forces beforehand. All right, so that is the entire process. Before, one little note I want to throw in here as well is regarding Newton's third law. So when solving for these forces, it's important to realize that the forces on one half are going to be equal and opposite to the forces on the other half. So either way will get you the internal forces, but if you look at the right half, you're going to get equal and opposite forces from what you would get on the left half of the body. So which side you determine, or which side you choose determines the direction of these forces. So here is the top half. If I solved for these on my kind of chain link piece, if I looked at the bottom half, I'd get the same normal force magnitude, same shearing force magnitude, and same moment, but each of those would be the opposite direction. So normal force is going down on the top, it's going up on the bottom. Shearing force is going to the right on the top, it's going to the left on the bottom, and then the bending moment, it is counterclockwise on the top, clockwise on the bottom there. So for this reason, it's important to show those final forces and moments on a diagram rather than just providing numbers, because I don't know if you worked with the top half or bottom half, left half or right half, etc. in all these problems. All right, so review of the entire process. Again, we're going to first solve for all those external forces and moments, at least all the external forces and moments acting on the side of the body we intend to work with. Next, you're going to draw a free body diagram of half the body, making the cut at the point of interest, so that cross-section should be the point you want to find the internal forces at. You want to include all those external forces on that half of the body. Make sure don't include stuff that you cut off on the other side. You want to include the unknown internal forces and unknown internal moments. Again, you've got 3 in a 2D problem, and then you've got 6, 3 forces, 3 moments in a 3D problem. After you set up the free body diagram, write out all the equilibrium equations based on the free body diagrams. And step 4, of course, is solve those equations for the unknown values. And those unknown values will be the internal forces you're looking at. All right, that's all we've got for today's video lecture. Thank you for watching, and I hope to see you again.